Okay, for the problems on this worksheet, we want to basically check the congruent triangles out for corresponding parts and then solve. So in this first set, number 9, we can set 8x minus 6 equal to 3x plus 9 and find out that x is equal to 3. For this other one, basically 5a angle is congruent to 2a plus 3 angle. So we set those together and subtract. We get 3a's is equal to 3, or a is equal to 1. For number 11, 4x minus 35 basically matches up with 2x plus 17. So we're going to get 2x's is equal to 52, which means x is going to be 26. For number 12, those two triangles are congruent. And so 3y plus 20 equals 7y, which means that 4y's is 20 and y is going to be equal to 5. Okay, if we look at number 13, it tells us that the two triangles are congruent, which means that we actually, the big triangle is an isosceles triangle. So the two legs are congruent. 5y minus 7 is equal to 3y plus 21. So that's going to give us 4y's, or 2y's is equal to 28. So y is going to be 14. If we look at number 14, by vertical angles, we can jump the 5x minus 10 across and then use triangle sums. So we have 90 plus 35 plus 5x minus 10 equals 180, which is going to be, I think, 5x plus 115 equals 180. And when we subtract 115 from both sides, we have 5x's is equal to 65. And that means that x is going to be 13. That's all we had to do for that one. We're doing WXV, so I want to make sure that how these triangles are situated. So I usually kind of trace them to see. And we can see that that 84-degree angle is going to be a vertical angle. And also the 6a minus 10 is a corresponding angle with W on the other side. So we could use triangle sums again and say that 6a minus 10 plus 52 plus 84 equals 180. So we end up with 6a is equal to 6a plus 126 is equal to 180, which means that 6a's is 54 and a is going to be equal to 9. For number 16, these triangles overlap, so it would be useful to draw one triangle separated from the diagram to kind of keep things straight. So off to the side, I'm going to draw another triangle and call it XYZ. Now, the long side of that triangle is a 4 plus an 18, so that's going to be 22. And the other matching side from the other triangle is going to be 9p plus 13. So we can set those equal to each other, and we end up with 9p is equal to 9, which means that p is equal to 1. Okay, we have some proofs to do on this next part. So we want to prove that JL is congruent to MK, or ML. JL is congruent to MK. So those two sort of hypotenuse-looking pieces need to be congruent to each other. So I'm drawing another triangle separate so I can keep these straight. KL is going to be congruent to itself. That gives us a side. They're telling us that JK is congruent to ML. That gives us another side. And also that angle JKL is congruent to angle MLK. That gives us an angle. So by side angle side, those triangles are going to be congruent. So we're going to fill in the blanks. Number 1's given. Number 2, angle JKL congruent to angle MLK is given. Reflexive is letting us say that KL is congruent to itself. So that's side angle side pattern. And by corresponding parts of congruent triangles, CPCTC, we can say that those two segments are congruent. In this diagram here for number 5, RT is congruent to RV, and they're telling us that the measure of TRS is equal to the measure of VRS. So we're going to take a step and have to make those congruent so we can actually use those in the proof. And then by reflexive, we have RS is congruent to itself. So that sets up a side angle side pattern for this. So RT is congruent to RV, that's given. And also the measure of TRS is equal to the measure of VRS, that's given. So that lets us say that with number 2, that angle TRS is congruent to angle VRS. That's definition of congruence. By reflexive property, we have RS is congruent to RS. So far we have a side angle, and then that sets up another side for the side angle side pattern. So those two triangles are going to be congruent. Triangle RTS is congruent to triangle RVS by side angle side. And then by corresponding parts, those two angles are going to be congruent, CPCTC. Look at number 6. They're telling us that ray AD is an angle bisector, so that means it's going to cut angle BAC into two congruent parts. So angle 1 is going to be congruent to angle 2. And then also they're telling us that AB is congruent to AC, which gives us really that big triangle is an isosceles triangle. And we want to prove that BD is congruent to DC. Or in other words, we could be asked to prove that D was the midpoint, kind of like the same thing. So if we look at the patterns, we have side angle side that will prove this for us. So step 5 is going to end up being side angle side. So we need to start with the bisector. AD bisects angle BAC, that's given. Then by definition of angle bisector, angle 1 is going to be congruent to angle 2. That gives us the A that we need. Then we're going to throw the other given in. AB is congruent to AC, segment AB congruent to segment AC. That gives us another side that we need. And then by the reflexive property, segment AD is congruent to itself. That's the shared side between those two triangles. That gives us the other S. So we have an SAS pattern for the two triangles being congruent. And then by corresponding parts, we have